All right, this is the third video in the construction Google presentation. We're going to continue working from the sill plate, which is down here. That's what was fastened to the concrete. You saw that in the previous image. If we go back to that previous picture, you can see the sill plate here running on top of the concrete, and here you see only the joists. In this image, we see they've put the plywood down, they've built the walls up on top, and they've got the roof framed already. So if we start at the very bottom where you've got the sill plate, they've got the anchor bolts identified. Anchor bolts you can't see in this picture, but are bolts that are put into the concrete, go through the sill plate, and that's what holds the wood structure to the concrete. You have the header joist, which is coming across, which all of the joists are attached to, and the rim joist over here. Working your way up from the joist, we have plywood that covers the floor. The plywood that they put down is typically a 3/4 inch tongue and groove, which means those pieces of plywood are fit together. The plywood is commonly glued down to the joist and nailed. If you have a house with a squeaky floor, where the squeaks come from is that plywood has not been glued down and is lifting away from the joists. So in modern construction now, they glue that to eliminate that. Inside of the walls, there's a variety of components. We're going to identify a lot of them in the next picture, but the regular pieces are called the studs. You've got the headers that span the doors in the window. This one has a rafter framed roof. Rafter framing is less common now. More common is trusses. Trusses come pre-made and get set on top of the structure once the walls are done. So we're not going to identify a lot of those things, but this is what the house would look like as it's getting framed up. This slide more clearly identifies all of the components inside of the framed wall. You're going to need to come back to this slide to help identify inside of the worksheet what each component is named. You can see here again the headers. Headers span over doors and windows. They use the same term for both. On the bottom, they've identified this as the sole plate. I also refer to it as the bottom plate. Either terminology is fine. The regular pieces in the wall are called the stud. So if it's not a part of the window or door assembly, it's just a stud. If we look at the door first, you have the king stud on the outside. The king stud goes from the top to the bottom. The header butts up against it. On the inside of the king stud, we have a trimmer stud. Now, the trimmer studs are labeled at the window, but in the doorway, it's the same thing. So a trimmer stud holds up the header and goes from the bottom of the header to the bottom or sole plate. So that's the door assembly. In the window, it's the same thing. You still have the header, you still have a king stud, and you still have a trimmer stud. All right. The only exception is now on the bottom, you're going to have a sill plate. The sill plate fits between the trimmers. This image is a little misleading because it looks like it sticks into that trimmer, but the sill plate goes in between the trimmers and is held up by what we call cripple studs, which are just short pieces of wood that support that sill plate on each end, and then they'll space it out in between. Now, inside of the wall, the studs are spaced 16 inches on center. So at no point can any of these framing components be greater than 16 inches from the center of one board to the center of the other board. In a lot of cases, it's much less than that, but it can never exceed that. Otherwise, the structural integrity of that wall would be compromised and the house could fail. Here you see more examples of framing. The windows here and doorways. This is another example of rafter construction. Here we have an example of trusses. You can see that these trusses are pre-built triangular pieces getting set into place one at a time. Traditionally, they'll use a crane or some kind of an industrial forklift to lift those into place and set them on the building. This greatly reduces the amount of time that it takes to frame the house because it goes much faster to set a truss than it is to create a rafter. Other things that happen in enclosing the structure are sheathing, which is the plywood that gets attached to the walls and roof. Siding, which could be vinyl, it could be brick, it could be some other type of like a stucco plaster. and roofing materials, which in this area is most commonly asphalt shingles, but also steel roofing is becoming more popular. Here we have a house that's in the beginning process of getting enclosed. You don't see the framing components anymore because they've been covered up with the OSB, or oriented strand board. That gets attached, the doors and windows are cut out, and then we use what we call building wrap. This white wrap is a weather resistant wrap that keeps the moisture from getting through the siding, and it keeps it out of our house. Here you can see around a window. Around windows and doors, typically what they'll do is use a very strong tape to tape that down so that there's no moisture that can get in around the windows and doors. Here we have more of a finished exterior. From the roof, you see from the plywood, they've labeled that as the deck. We put down felt paper. It's basically like a tar paper that provides a waterproof barrier while you're installing the roof. There's waterproof underlayments in high risk areas, anywhere near the gutter, in valleys, or over a hip. A valley is where two pieces come together and they leave a concave or a valley. A hip is where they come together and it's a raised area. Flashing anywhere around a chimney or pipes that protrude from the roof, those are all using what we call flashing. The ridge is the top of the roof. We use ridge vent that allows heat to escape. If the roof is not properly vented, the shingles will age prematurely and they'll curl up. Typical asphalt shingle life expectancy is about 20 to 30 years, but with poor ventilation, a roof could go bad in as few as 5 to 10 years. Here we have a gable. The gable is when the side of the roof is opened. That is different from the hip, where now you just see the roof. A gable is where you see the triangle side of the roof of the house. Those are the primarily important things. Here they've got a piece of gutter. The gutter would go along the edge, and the downspouts, so on and so forth. After the house has been enclosed, it's been framed, it's been sided, it's been roofed, now we're ready to start installing what we refer to as the utilities. The utilities are going to include all of the electrical, which are your lights, your receptacles, the water, which are your supply lines, your waste, which is going to be like the stuff that comes from the toilet, from the bottom of the shower, anything that's wastewater, could be gray or black water. Gray water is water that's coming out of a sink. Black water is what is coming out of the toilet. Your climate control, which is going to be your heating and your air conditioning, and communication, which is going to be your telephone and cable lines. Here you see a heating and venting air conditioning professional installing a furnace. In our area, we require a more substantial furnace. In some areas of the country, they may get away with just a heat exchanger, but here we need high BTU furnaces. The furnaces are vented using these white pipes to get the carbon monoxide out of our homes. Here you can see some wiring. The wire comes up into the box. This box would be a receptacle or an outlet. You see these two metal pieces here. Those are nail guards. That's to prevent somebody from accidentally driving a nail into the wire. If a wire is ever punctured with a nail, it becomes a fire hazard and it needs to be fixed. But here you see the wire coming into the box and going through the walls. This is a circuit breaker panel. Each one of the circuits or areas of the house is to a specific circuit breaker. If you draw too much electricity to any one outlet, it will trip the breaker and you got to reset it and turn it back on. Prior to circuit breakers, we used fuses, and when a fuse blew, it actually had to be taken out and replaced. A circuit breaker can trip and be reset many times, whereas a fuse was single use. Without circuit breakers, if you use too much electricity, the wires would overheat and be a fire hazard. Here you can see some plumbing going into the house. The white is PVC pipe. That would be all the waste removal. It's a little bit harder to see, but these are copper lines. The copper lines are what provide water So that would be your hot and cold. There are two different lines. One comes directly from the well, one comes from the water heater to